Hello, this is Valerie Shirley. Today I will be recording Journal 6, the single sample t-test, and I'll be demonstrating how to perform a single sample t-test using SPSS and interpreting the findings. So let's get started. We will be using Chapter 7 of the Cordy textbook that we've used for this semester. And so here we go. In 1997, Nabisco issued a challenge. They claimed that each bag of Chips Ahoy cookies contains at least 1,000 chocolate chips. Consumers were told to count the chocolate chips and try to prove Nabisco wrong. Because this would prove a huge undertaking, we are going to use the single sample t-test to help us determine if Nabisco's claim is true. To begin this, we are going to use the 6 steps of a hypothesis. So in step 1, we determine the statistical test that we're going to use. And first, we need to begin by knowing that a regular bag of Chips Ahoy cookies has 36 cookies. And so we are going to divide 36 into the 1,000 chocolate chips and get an average of 27.78. So each cookie contains approximately 27.78 chips, according to Nabisco. 27.78 is our population mean. Okay, so the population value is known, 27.78. And now we need a sample of cookies, and we need to find our sample mean to see if there's a statistical difference between the sample mean and the population mean. Unfortunately, Nabisco has not reported a population standard deviation, so the single sample z-test cannot be used. It is possible, however, to calculate the standard deviation from a sample, which means the single sample t-test can be used. So we are going to take 10 cookies from our bag of Chips Ahoy cookies. Each cookie will be soaked in cold water. The cookie part will wash away and the chips will be counted. So after counting the chips, the cookies contained between 22 and 29 chocolate chips with a standard deviation of 2.69. Because the average of 22 to 29 is 26.10, and that's where we get our standard deviation from. And so the next thing that we need to do is, in step 2, check the assumptions. So the random sample assumption was violated because our sample is not very random. We're taking them from one package of cookies, and we just have 36 to begin with. But given the focus on quality control at Nabisco, we think that it is reasonable to generalize the results for a larger population of Chips Ahoy cookies. We'll operationalize the independence of observations assumptions, as most researchers do, to consider it not violated, as no case is in the sample twice, and each cookie is assessed individually. Similarly, the normal assumption will be considered not violated under the belief that characteristics controlled by random process are normally distributed. So we can see in our SPSS that we have our 10 cookies and the number of chips that each cookie possesses. And now we are going to step 3. And here we are going to formulate a hypothesis. And before I formulate the hypothesis, I do want to point out that I wanted to see where the cookies fell in a standard deviation. And so I used SPSS to perform a histogram. I went from analyze to descriptive to frequency, and then under charts, I went to histogram. And here we got that information right here. Okay, so even though there's some variance from one cookie to the next, it all fits under our bell curve. And so we know that going forward. Okay, now we are going to go to step 3, which is to form a hypothesis. On page 245, we read, it seems reasonable to do a non-directional two-tailed test in order to follow the possibilities of more chips than promised or fewer chips than promised. So we have 2 hypotheses to look at. Hypothesis number 1 would be that the mean population of chips per cookie is equal to 27.28. And the alternate hypothesis is the mean population of chips per cookie is not equal to 27.28. And now that we have our hypothesis, we're going to go to step number 4, and we are going to be setting the decision rule. Because it seems reasonable that making a type 1 error is not catastrophic, we can use the traditional alpha level of 0.5, and the two-tailed test is being used. So the critical value of T is within 9 degrees of freedom. And the way that we determined this was to, in the Cordy book, turn to page 21. And we can see on the critical values of T chart that if we are going with 9 degrees of freedom and a 0.5 on a two-tailed test, that takes us to our second column, and we would have 2.262. And so the decision rule is if T is less than or equal to negative 2.262 or greater or equal to positive 2.262, we will reject the no. But if T falls between negative 2.262 and positive 2.262, we will fail to reject the no. And so now that we have all this determined, we can go to step number 5, which is running a single sample t-test in SPSS. And so we are going to go to analyze, from analyze, compare means, and from compare means, we're going to go to one sample t-test. And originally, we had our list of variables that were available in the left-hand column, and I just moved that over to the variable that would be tested, and the test value is going to be the 27.78, and that was the population mean that we calculated at the beginning of the video. All right, so now that we have that determined, I do need to throw out a disclaimer. I am not able to do a Cohen's d because my SPSS is 26, and you can't do a Cohen's d value until SPSS 27. But we have an alternate way to go about it. So I'm going to go ahead and say, okay, here. And I've done it a couple times. So here is my most recent time to do it. And now we have our data, and we can arrive at step number 6, which is interpreting the data. Okay, so the first step in interpreting the results is to determine if the null hypothesis should be rejected. And if the null hypothesis should be rejected, the second statement in the decision rule is true. minus 2.62 is less than 1.98. And I guess I needed to stop right here and show us our numbers on our one sample t-test. Okay, so here we have our 10 cookies. Our mean is going to be chips per cookie. That's 26.1. The standard deviation is 2.68. And then the standard error mean is 8.85. All right, and here that takes us as far as we want to go for just a minute. Okay, so if we're looking at the 26.10, we can see that the population, the sample mean, does not have a huge difference from our population mean of 27.78. It's not statistically significant. There's not enough evidence to suggest that Nabisco's claim is exactly true, or if their guarantee is a little off. And so we can move forward giving Nabisco the benefit of a doubt. But we also want to look at the Cohen's d. And again, because I cannot do that with my SPSS, the way that we are going to calculate that is with our, okay, the Cohen's d is determined by the sample mean minus the population mean divided by the standard deviation. And that is going to be 26.10 minus 27.78, which takes us to minus 1,068. And that's over 269. And that's right here, our standard deviation, that's over 269. And the total there is 0.62. And so 0.62 is our Cohen's d value. So we're going to look at the table on page 32 in the Cordy book. And here we see in the effect sizes in the social and behavioral sciences chart, table 7.3, that we have a medium effect. So it's not a large effect, but it's more than just a small effect. So that suggests to us that we should do this experiment again with a larger sample of cookies. Okay, let's go ahead and look at the confidence interval here. Here is the lower confidence interval minus 3.6, and the upper is 2.4. And 0 falls within that range. So again, there's probably no significant difference. However, because the range falls in the negative area, we are going to accept that there must be fewer than 1,000 chips per bag, and we are going to conclude that a larger sample needs to be taken. And this is shocking news for me because I believed that Nabisco had 1,000 or more chips in my bag of cookies for most of my lifetime. So anyway, so much happened here. The biggest thing that threw me for a loop was trying to figure out the Cohen's d, but it all came out in the wash there. So this concludes my single sample t-test video. And I hope you have a wonderful day.